Let's start this lesson off with the puzzle of O2. So O2 is a very common molecule. It's diatomic oxygen. You breathe it every day. If we try to draw a dot structure, oxygen is in column VI, which is column 6. So it gets 6 dots. The 6 dots are arranged around the oxygen using all 4 sides of the imaginary square table. 1, 2, 3, 4, 5, 6. So there are 6 dots around the square table. Try to bring in a second oxygen, another oxygen atom, again with 6 dots, and see if you can put them together in a way that obeys the octet rule. This will be a challenge. So if you don't succeed, I'll show you in a couple minutes how to do it. Alright, so I'm hoping you realize there's a challenge here that needs some new ideas. If you were to take this oxygen, you could pair up dots like this, and that would make a nice bond between the 2 oxygens, but then you'd have this leftover single dot here and this leftover single dot here. You would not have an octet. You'd have 2, 4, 6, 7, not 8. And similarly, if you said, well, I'll line up these dots, then same problem. 7 and 7, you need 8 and 8 without adding any electrons. Some of you may have thought, well, maybe I can do this if I have 4 oxygens, which is true. If you had 4 oxygens, you could line up all the single dots. But it's O2, it's not O4. So here's a solution that some of you may have thought of. Take this oxygen and drag it over, drag it over, drag it over, drag it over on a diagonal. And you can see that these dots line up very nicely if you do that. And you do get pairs of dots. If you do this, you should see a pair of dots there. You should see a second pair of dots there. Each shared pair is a bond. So, shared pair of electrons, a covalent bond, and we have 2 of those. 2 of those. So this becomes a double bond. A double bond. So there is a double bond in the middle of the O2 molecule. And the dot structure could be represented like this, or a slightly different way, which I'll show you on the original worksheet. Okay, on your paper, if you like the diagonal method, if it's intuitive for you, go ahead and use it. Here's a blue oxygen with its 6 dots around the square table. I'll use a red oxygen as its partner on the diagonal square table, like so. Here's where we see the 2 covalent bonds, 1 bond there, 1 bond there. So it's a double bond, and can be written this way: O, 2 lines, another O. So that's a double bond, which you should write on your paper. Some people don't like the diagonal. So if you don't like the diagonal, or don't see it clearly, or can't draw it clearly, then the alternative is to do this. The original 6 dots for the oxygen, the red oxygen, 6 dots like so. So you may have gotten to something that looks like this originally, where you say, I can bond it, but I can't fill the octets. And then what you do is you take your eraser and you erase these single dots here, and then you move them to the middle, 1, 2, 3, 4 dots. And that's a double bond as well. It might look to you like simple math, O equals O. So if you see this in chemistry, think that's a double bonded oxygen. That's the O2 molecule, not simple math. The diagonal method works for some people, but not for many people. And therefore, I'm going to show you a method that I like called the eraser method. Let's start with something that we can draw a dot structure for. C2H5N. So 2 carbons, 5 hydrogens, and a nitrogen. Turns out there's more than one way to put this together. So I'll show you the method twice. Let's start with the green version. This says make all single bonds first. So let's try that. Carbon. And then let's put a nitrogen next door. So I have 5 electrons for the nitrogen. You'll notice I'm leaving the hydrogens till the end. This is usually a wise strategy. Here will be my second carbon. Okay, that's a skeleton. It has 1, 2, 3, 4, 5, 6, 7 total bonding slots available. I only have 5 hydrogens. Therefore, I know there'll be some unoccupied spaces. Let me throw the hydrogens in as orange. I can be strategic here. Since I know that I can't fill all the slots, I'll want to have 2 slots left open that are neighbors. Okay, so there's a reasonable arrangement of 5 hydrogens. You will notice that the problem lies right here. There's a lonely dot and a lonely dot. It's okay, we'll fix that. The second step in this process says erase the single dots, the lonely dots, and move them to make a double bond. I will try to show what that means. I am copying faithfully the structure I have above. Please do this on your paper as well. Notice I'm making the hydrogens big so that they are sharing 2 electrons. No tiny hydrogens that only bond to 1 electron. It's an invited guest at the table. Alright, now here I'm going to use my eraser tool. Now I'll use my eraser tool here. I'm erasing this dot. It's lonely. I'm erasing its neighbor. It's also lonely. I now bring those 2 electrons back. And they'll come back in between this C and this N where they lost dots. They didn't really lose them. We just moved them. So now you should see in this space here, that's a double bond. I'm rewriting this structure as a line structure. ICC with a bond to the H on top, bond to the H on the left. That's this part right here. A double bond to the N that's in the middle, which has a single bond to the other carbon, which has 3 bonds like so. That's the line structure that corresponds to this dot structure that has a double bond. Here I'll start you off with a second arrangement of the same atoms, and then I'll ask you to try to make a structure that includes a double bond. Let's try this. C, 4 dots. Second C here with 4 dots. And then an N here with 5 dots. 1, 2, 3, 4, 5. There are a couple different ways that this can become a molecule with octets for all. I'll let you try to find them first, and I'll draw the structure so you can check your work. Here I have 2 structures which will work. These will form double bonds. You can see here, 2 single dots next to each other that can form the double bond. And this structure there on the carbon and nitrogen. This black structure will not work. So if you ended up here with a single dot on the N and a single dot on the C that's removed from it, then you can't make a double bond here. They need to be neighbors. They need to be neighbors. And you might also have ended up with 2 single dots on the same atom, like 2 single dots here on the nitrogen. You might have, for example, put this hydrogen over here, and then you end up with these 2 single dots right there, and there's nothing you can do about that. That's also bad. So you need neighbors, 1 on each side, to make the double bond. So now I'm ready to make the double bond here with the eraser method. Here's my eraser. This is a lonely dot here and a lonely dot here. I'm erasing this lonely dot, and I'm erasing this lonely dot. And I will move them to the middle. 1 X and 1 dot. And this then becomes the double bond right here. So one of the molecules looks like this. Here's my second one that I've redrawn in blue. Once again, I'll get out my eraser. And this is a lonely dot and another lonely dot, so I'll erase them. And I'll move them to the middle. Move them right here. So there's one lonely dot here and another lonely dot here. They'll move to the middle. So there's now a double bond right here. So I can draw that one. I'm just tracing the original diagram where a shared pair of electrons is a bond. These 2 molecules are called isomers. They have the same parts, which is what isomers mean, the same formula, C2H5N, but they're not the same molecule. The positions of the bonds are different, and therefore they have different properties, and they have different names. They're not the same molecule. Alright, so I'm hoping this has meaning for you, that you can now make double bonds where you need them. There are plenty of molecules that have no double bonds, so don't jump overboard and start making double bonds everywhere. They occur in certain locations where they are needed, where you don't have enough atoms to fill all the slots at the table. Okay, here's number 3, a chance for you to practice. This will be a good choice of atoms. C2, 2 carbons, 4 hydrogens, 1 oxygen. There are a couple of ways to put this together. That's why it says find 2 ways. But you will need a double bond, so make sure that you use the eraser method or the diagonal method to do this. You can see I've given you 2 boxes here, your structures, 2 boxes. Try number 1, try number 2, 2 different structures. I'll show you answers here in these spaces to the right. There you have it, 2 different structures for the formula C2H4O. This one would be commonly written CH2CHOH to properly describe how it's put together. This green one would be described as CH3. CHO. You can see that this again shows how it is put together and is more specific than the generic C2H4O.